Hello, this will probably be the last video in the course summary of E2015 Electrical Circuits and Networks, where it is to discuss the three-phase systems, what three-phase systems really mean. So we have two circuits here, A and B. That is, in A we have two sources, VP cos omega t and VP sin omega t, and B is a slightly different case. But let's see what this means. So if we have VP cos omega t and VP sin omega t this way, then and the two resistors being equal RR, then we'll have the total power in the resistors equal to Vp square by R. That's because the cos square and sin square terms will add up to 1, and the total power, as you can see here, is a constant, although the source is a time varying one. So the goal is to get constant power at the load, total constant power. So this was for the sources, two sources with a pi by 2 phase difference. Now what if we take three sources with 120 degree phase difference, that is Vp angle 0, Vp angle minus 120 and Vp angle minus 240, Vp being the peak current, and this entire term representing the phasor. Now we connect it to three equal resistors, we'll get total power delivered to the resistors equal to 3 by 2 Vp square by R. The constant is coming because sum cos square theta cos square 1 plus cos square theta plus 120 plus cos square theta plus 240 degree turns out to be a constant 3 by 2. Now uh, if currents IP and IP, that is the peak current, flow through each of these branches, then the current flowing through this lower branch will be 0, because again cos theta plus 120 plus cos theta plus 240 will add up to 0. So no current in this particular wire. In the A case, we used four pieces of wires, and in B case, we have to use only three wires. So, and we also get a constant power in the constant total power in the load. So B is a more optimal case. Some of the currents is 0 in this branch, and this in what we find in B is basically the three-phase system. Now, this three-phase system on slight rearrangement can be represented in a star connection. That is B, R, and Y being the colors used to represent these three terminals, N being the neutral point, and if we have a star connected load ZB, ZY, and ZR, and connect blue to blue, red to red, and yellow to yellow, we'll have what we call a three-wire system. And some more terminologies here. Line to line voltage is VRY, that is VR minus VY, where VR and VY are line to neutral voltages, that is taken with respect to this center N, central node. And if we usually have a source always connected in the star form, not in the delta form, whereas the load can be star delta anyway, and it can be converted using the star delta conversion formulas. So the source we usually take of this form only, that is the peak current is same for three sources. If the load has ZY, ZB, ZR equal, we call it a balanced load, an unbalanced load otherwise. And on connecting these, we'll if it is a balanced load, we'll get a constant power delivered, a constant total power delivered to it. And this concludes the discussion of the short quick summary of this particular topic, that is the three-phase system. We discussed inductors in the last video, and this sums up the summary. So I hope this helped you to see some concepts you might have forgotten, or look at the concepts maybe in a different way. And yeah, that's it. This was the last video, so part of the journey is the end. Thanks for watching, and I really hope it helped.